Assalamualaikum warahmatullahi wabarakatuh and have a good day everyone. We are from Group 1, Statistics Section 5. Today we are going to present our problem-based learning entitled How Far Does It Roll? Before we started our presentation, I would like to introduce you to my group mates. The first one is Amira Hani, followed by Damia Dayana and Khairunnajlaa. Lastly, myself, Norhaliza Dayana. For the filler table part, we already divided to 4 columns. The first one is fact, the second one is ideas, the third one is learning issues, and the fourth one is action plan, resource needed. In every column, we already put 5 points. First point is for the fact, plastic bottles of the same size and shapes are used. For the ideas, the amount of water may influence rolling distance. For learning issues, how does the amount of water affect the bottle's inertia? For the action plan and resource, we need to review basic physics concept on inertia and rolling motion. For point number 2, for the fact, different amount of water are tested. The ideas for number 2 is the water distribution inside the bottle may affect its stability. For the learning issues is how does the distribution of water inside the bottle influence the rolling distance. The action plan or resource needed is to research on liquid dynamics and stability of rolling objects. For the point number 3, fact is the distance traveled by each bottle is measured. For ideas, more water may increase the rolling distance because of greater inertia. Learning issues is how can I precisely determine the distance traveled by the bottle? For the action plan, we need to achieve consistent readings, use a meter stick or measuring tape on a level, smooth surface. For the point number 4, the fact is observation regarding rolling behavior are documented. The ideas is less water may result in a wobbler roll. The learning issues for point number 4 is what are a few commonly used methods for observing rolling behavior. For action plan is document observation carefully, possibly using video recordings for analysis. For fact number 5 is the experiment is repeated for several trials. The ideas is measurement must be consistent and accurate. For the learning issues is why is it necessary to repeat tests several times? And lastly, for the action plan, we need to conduct many trials to average out conditions and explore the significance of repeated observation in scientific research. In this section, we have recorded the data for this experiment. We add water in amount from 50 milli to 500 milli.
into the container and measure how far it moves. Notice if the movement is straight or shaky. With 550 ml, the container moves 15 cm and wobble a little. At 100 ml, it travels 32 cm and travels straight. At 150 ml, it travels 53 cm and stays straight. At 200 ml, it becomes 64 cm and straight. And at 250 ml, it covered 76 straight. With 300 ml, the distance are 85 cm, also straight. At 350 ml, it traveled 101 cm but wobbled. With 400 ml, it became 90 cm and a little wobble. At 450 ml, it traveled 65 cm and wobbled a bit. Finally, with 500 ml, the container moved 118 cm and moved straight. Overall, as the amount of water increased, the travel distance also increased, with the container being the most stable and traveling the furthest with 500 ml of water. For the next slide is a graph of the distance traveled versus the amount of water. We create this graph using the data collected from this experiment. I also included a regression line for better understanding and analysis. Finally, for the calculation, I made some calculation using simple linear regression. Okay, firstly, I find the mean for amount of water, and the answer is 275 ml. Next is distance traveled, which is 72.9 cm. And then I find the deviation and covariation, variance, regression coefficient, intercept, and the last one is coefficient with the 82%. So, a basic linear regression shows how water quantity impacts distance traveled with an R power of 2 of 0.8628 with a percentage 86.28 of distance variation is explained by water quantity change, providing a clear insight for further analysis.
In conclusion, as the amount of water in the bottle increased, the bottle traveled a greater distance due to the increased inertia. However, this relationship is not straightforward. Adding more water does not always result in proportional benefit. Instability occurs at low 50 ml and high 350 ml water volume, while moderate amount 100 to 300 ml provide optimal stability and efficient rolling. Linear regression show a strong positive correlation between water volume and distance traveled. Therefore, while more water generally help the bottle travel farther, there is an ideal range of water volume where the bottle rolls most efficiently and stably.
Now, let's summarize the key findings of our experiment and draw our conclusion. First, we confirm that the amount of water in plastic bottles significantly affect the distance it rolls. As we hypothesized, bottles with more water generally travel further due to the increased mass and inertia. However, our experiment also revealed that rolling stability played a crucial role. Bottles that roll straight went much further, while those that wobble lost momentum quickly due to the increased friction. This was evident in some bottles where unexpected lower distance were observed due to instability. In conclusion, our experiments support the hypothesis that has more water in a plastic bottle result in a longer rolling distance due to higher inertia. However, this effect is moderated by the stability of the rolling motion. So, to gain more precise insight, future tests should focus on better controlling the rolling process and examining different surface type of bottle shape.
That's all from me. Thank you.